Hi guys, so this is a revision material for your upcoming Unit 1 exam. The idea of this is it's not going to be massively detailed lessons, but it should be concise, exactly what you need to learn to be able to pass the exam. In fact, get a distinction in the exam if you follow it through exactly. Now, most of this material is, as I said, going to be quite truncated, so I'm not going to be going into too much depth, but as I said, focusing exactly what's on the specification. All right, so there's the first point. Now, the first thing A1 that you need to learn about is decomposition. Now, decomposition is the idea of breaking down problems, yeah, so that it can be solved easily. Now, for example, if you had to develop a new game, say for example you're trying to develop a new, one of the popular games, um, the developers would have to have different parts of it to be able to work on. Because if everybody's trying to work on the same part together, then you might have overlaps. And also, it helps to be able to have each person focus on their part, and then at the end of it, we'll bring it all together to have the solution to the large problem. So decomposition, as the name suggests, is the idea of breaking large problems and making it into smaller parts so that they can be solved easily. Okay, so those smaller parts in this instance are called sub problems, and then you can of course develop sub programs. All right, so hopefully you've got that. So the benefit is that it helps to work in teams. Right, then the A2 is pattern recognition. Now, after you've decomposed a problem, you can then try to identify patterns within that particular thing so that when you come to do the code for it, you can then easily replicate things that are repeated. For example, right, a typical example is if you're playing a game, let's say a game of Super Mario. I know it's a retro game. The screen is being repeated, as you know, there are certain actions that are repeated in the background. Okay, so you realize that that is a pattern that's repeated, so you develop that particular thing, and all you then need to do is re- reiterate that so that it keeps coming up every so many intervals. Okay, so finding similarities, yeah, or patterns amongst small problems after they've been decomposed, and then it makes it more efficient because you don't have to then repeat yourself. Okay, so that's what pattern recognition is about. So making for efficiency so that you don't have to keep repeating the same thing as in writing the same code over and over again. Okay, so that's A2 pattern recognition. Right, then generalization and abstraction. Okay, so pattern generalization is the idea of identifying information that is required to solve a problem. Okay, so again, seems very similar to what's been said so far, but generalization in this case is saying to ourselves, okay, what is common? What is common amongst different parts of the thing that we're trying to identify? Yeah, but this time round, it's to do with information. Yeah, previously we're looking at the data or instructions that needs to be repeated. In this case, we are taking it off, yeah, from looking too inwardly, and we're looking out to see what are the general bits of information that's required. Highly unlikely you're going to be tested on that, but it's worth knowing. What you will be potentially tested on is abstraction. Now, the idea of abstraction is when we have a large problem that we want to solve, but there are things that aren't necessary. Okay, so for example, I'm trying to make a new sat nav. Okay, of course, the sat nav needs to tell someone the road that they're on. It needs to tell them certain bits of information, maybe traffic information, where the traffic lights perhaps are, things like that. But it would not need to have information about the tree that's on the road, on the side of the road. It would not need to have information about, I don't know, buildings on the side, where the nearest big supermarket is, or perhaps where the church or the mosque or whatever it might be on the road is. So those bits of information are abstracted out. So we've filtered out the things that are not necessary, and we're focusing on the thing that is necessary, which is the layout of the road, where the particular speed restrictions are, for example, the turns, etc. So we're focusing more on what is required. So abstraction, again, just to reiterate the description of it, is identifying information that is needed to solve a problem, and then filtering out information that is not required. Okay, that's A3 completed. Now A4 seems very basic what's been said here, but algorithms design is the idea of following a step-by-step instruction to be able to solve a problem. Yeah? So you would have heard the word algorithms being used to describe computer programs. So an algorithm really is how we represent a solution to a problem on a computer. Okay, so algorithms are step-by-step instructions of solving a problem. Right, so we will leave this here to complete A, and B we will start in the next video.